And so they just announced it in the BGP, the routes there, and this was propagated beyond the borders of the country for sure, and this was because YouTube was not reachable. And if you look at the IANA site, for example, you can really see how the routing tables are flapping because YouTube announced it back with a smaller subnet, so they can be reachable again.
So, okay, that means if you, for one, part of this global BGP community, you can nearly announce every route you want. There is some kind of route filtering, but on a global scale, on a central node in the internet, you can't filter all these routing entries. So maybe you've heard of the, what was Last Hope? I think last Hope there was something with a global BGP man-in-the-middle situation set up. Ask me later if you're interested. Okay, so BGP got some security mechanisms, which are, as I said, not based in the BGP protocol itself, but they're given over to TCP, which means BGP uses the generic TCP MD5 signature option, which is defined in the RFC 2385. And suddenly you will just think, okay, yes, MD5. I've heard about MD5 on the last CCC. No, okay, but MD5 isn't really a good hashing algorithm. That's, in this case, not the main problem, so you can't just assume the MD5 hash because you don't know the secret password configured to secure MD5. But MD5 is calculated on a modern laptop in, I don't know, in like nothing. Okay, but they're working on it. So there is a working group of the IETF, which just throw out some drafts which will extend these TCP security option. Okay, so, but consider for yourself, does this really add a security value? Both operators has to configure the same key, and that's the point where everything breaks off normally. So, okay, something is wrong with BGP. Oh no, our routing is not working, so let's just, to be sure, let's remove the secret keys for first, and then have a look deeper into the configuration. Okay. So, you see, there is a security mechanism, but with our side, we were on some big customer sites, there is nearly nowhere used.
The problem is also with the MD5 key that you need a process to change these keys. And in the moment where you change a key on one side, you also have to change on the other side. If not, your BGP session falls down and the routes are removed from the table.
Okay, so far for BGP in general. Now we'll come to the first fun part. This is one of the meat slides. We got some tools coded in early this year. One of this is the BGP CLI, which is a command line interface for the BGP routing protocol, so you can manually establish BGP sessions and propagate some update statements with whatever you want. You can actually brute force live MD5 keys, but this is more like a log file generator. So you won't use this actually, but use the second tool, which is the BGP MD5 crack. You will see live now. Okay. First of all, I'll make this a little bigger.
Thing is, if you can crack it offline, because you have already a hash in the packet, so can crack it offline with a C program, which is much more efficient than cracking it over the network. We are live connection, which will all be sent over the network, generate logs, and it's not even that fast. So there is no point in doing that. You just sniff it and let it crack offline on your laptop. All the demos assume that you are in the core the core that you are in the network of a provider. So there's normally in all these networks there's a trusted core assumed, but
I'm not going to allow you in my core.
Sorry?
I'm not going to allow the two of you in my core.
Yeah, that's true, but
that's good for you. So, okay, just to get on with the demo, we got a PE router here, which got a global routing table looking like this. So we got some C routes which are directly connected. We got one OSPF route, but the main part is we got no BGP route. So in the next step, I will just take my notes. And, whoa. So, and launch the BGP CLI. And I just have to configure some session parameters, which means, okay, I'm going to propagate autonomous system 2, and I have an idle time of 8 seconds, which is just for demo purposes a really short time. Okay, after that, I'm going to establish my BGP connection. So I'm connecting to a peer. I have to say, okay, I need to be configured as a peer on this, on the other side too. So, but this means you just need to get into the position of a valid peer. Either you can do this by hard spoofing the wire or by doing something like, I don't know, ARP spoofing or stuff like that. We are not talking about how to get into the core, but what you can do once you are in the core. Okay, so I got an BGP session up and running. So you see the PE just logs, okay, I got a new neighbor up. And after that, I can build some BGP update statement with this statement, and it just says, okay, hello, I'm the next hop for some new network. So once I send this out with the update command, you can see on the other side a new BGP route appearing, which is just this network, and the next hop is my laptop. Okay, seems to be really easy, doesn't it? So we're going to make this a little bit harder. So I'm changing to be another peer now, and this peer is secured by an MD5 shared secret on both sides. So you will see this peer disappears, and if I try to connect to this peer like I did to the other one, this won't work. So we get a timeouted connection, and on the other side, we got a log message, okay, bad digest or no MD5 digest from this peer. This is because all my TCP SYN packets to the BGP port are not MD5 signed, so the router just drops them. Okay, but in the other way, the router sends me TCP SYNs too, which means I can just sniff one of these SYN packages and run a brute force attack against.